Hi and welcome to the part 3 of this Docker training module. So in this video we will basically continue to explore more commands and concepts in Docker. So in the last video we created few containers and we then removed it. We saw how to manage containers, how to stop it, how to start it, how to create containers in attached mode or detached mode, and what is the difference between an attached mode and detached mode. So we saw all these basic concepts. Now let us see that when we create a particular container, how we can customize and manually allocate certain amount of memory and CPU to a particular container. Because as you could imagine that if we are creating containers for our application, then we would like to have the flexibility to allocate certain amount of resources for that particular container, because all the containers having different applications will not need same amount of resources. So we must have that flexibility to set up a particular amount of resource to a particular container. So now we will see two examples where we will allocate a specific amount of memory and also specific amount of CPU for a particular container while creating the container. So I'll take an example of a web application where in one container we will have the web server and in another container we will have a MySQL database. So in order to create the container for the web server, we can give the command docker run -name and let us give the name as container1. So remember that in the previous example which we saw in the last video, we were not giving any name, and hence Docker engine was giving its own name, a user friendly name to the container. But here by using the tag -name, and we can give our own name to the container, and in this case we are giving the name as container1. So this particular container that we are creating can always be accessed or identified using the name container1. And then we can give -it, which is to denote interactive terminal. So our interaction with this container will be in interactive mode, and then we can give -d, which is to run the container in the detached mode. So we will create an Nginx web server, so we can give the image name as Nginx. Now if you are not familiar with Nginx, it is simply a web server using which we can run our application in our local system. So it is simply a web server which you can directly use and run your application, and the Docker Hub already has an open source image of Nginx available, so we will simply pull that image and we will create our container. So here we can simply create this particular container by executing this command, but instead of that we will allocate a specific amount of memory by using the tag -m, and we can give a specific amount of space, say for example 64 MB. So in this case, when we create this particular container, the maximum amount of memory that it could allow is 64 MB. So basically we are setting the limit for the memory resource here. Similarly, we can also set our limit to the CPU resource, but we will see it later. So now let me execute this command. So as you can see that the image is getting pulled, and once image is successfully pulled, automatically the container will be created and it will be moved to the running state. Don't worry about this warning, it is something related to the internal kernel functionality. It is about memory swap. Warning can be safely ignored. So now let us check whether our container got created or not by using the command docker container space ls. So as you can see, our container got created successfully with the name container1. So the name which we passed in our command, which is container1, can be used to identify this particular container. Apart from the container ID, we can also always use the container name in order to identify this particular container. And also if you notice, we have 80 mentioned as the port for this particular container. It is because this particular container hosts the Nginx application, which is web server. So that web server can be accessed using the port 80. We will see more about ports, but as of now, the important point here is that there is a limitation in the memory resource of this particular container, which is 64 MB. That is the maximum memory that this particular container can support, because that has been specifically allocated by us in the docker run command. And other parameters, as we discussed in the previous video, they are self-explanatory, like container ID, created status. And here we have the ports 80, which we will discuss soon, how to do port forwarding, how to access a particular container using its public IP, and all such things we will explore soon. But just to give you an idea that this container is basically saying that the application which it hosts can be accessed using the port 80, and if we map this particular container port 80 to the docker host port 80 by using the port forwarding concept, then automatically you will be able to access the application or the web server in this case from your external network. And we will do port forwarding and see how it's done very shortly. But before that, I want you to get introduced with another command which is called docker inspect. So we can write docker inspect, and then we can pass the name of the container for which we want to inspect the configuration. Docker inspect output basically provides the detailed information of all the configuration related to the container. So basically it gives us the information on the constructs controlled by the Docker. and the result or the output of the Docker inspect is in the JSON array format. So what are the different information that you can find in a Docker inspect, right? That is an important question to answer. So you can find information like your container's instance IP address, you can find the MAC address, you can find the log path, the image name, list of all port bindings. So what are the different ports on which your container is running, or you can bind those ports to in order to access various services of the application which is running inside the container. If you want to find a specific port mapping, you can get that information, and also you can get all the information related to the network settings. So all such information you can find in the Docker inspect command. It is one of the very important commands which we will be using in Docker frequently during our operational activities, because it gives us the overall picture of all the configuration and settings of a particular container along with its application as well. So most of the parameters in this particular output are self-explanatory, like for example container ID or the state in which the container is running, the image ID or the network settings. But if you want to understand any specific parameter in this particular configuration, then you can definitely visit the official website of Docker and you can go through the Docker documentation for the Docker inspect command. So now let us move on to see how we can create a container by allocating a specific amount of CPU resource. So this is the command using which we can allocate certain amount of CPU resource to the container. So as you can see that we have given -C614. So what does it mean? So for example, in total, if you have 1 GB of CPU resource available for your containers to run, and in that case, if you want to allocate, for example, 60% of the CPU resource to one particular container and remaining 40% to another container, then if you calculate, then 60% of 1024 MB is nothing but 614 MB. So in that way, you can plan like how much of the CPU resource you would like to allocate for a particular container. So in this case, since we want to create this container with 60% of the CPU resource, so we can give -C and 614, and all other parameters, as you can see, is something that we already discussed. Like for example, -DIT, which is nothing but we are running this container in detached mode as an interactive terminal, and then we are giving the name as DB1 for the container, and we are pulling the MySQL image. So basically, this container will be created with the image MySQL, where you will be able to access the MySQL application. So let me write the name of the image MySQL, and let's name the container as DB1. So as you can see that the image is getting pulled, let it install and download. So as you can see that the installation is completed and also a container has been created. So now if we check Docker PS, then as you can see that container of the web server is currently running. So the container of the MySQL is yet to come up. So if you now give Docker PS -A, then as you can see that we have the MySQL container running in the exited state. So now this MySQL container will be allowed only to use 60% of the total CPU resource from the Docker host. So this was just to give an example. So similarly, you can design all your containers in such a way that you can allocate specific amount of resources to all the containers to enable optimum utilization of the underlying host machine's resources. So in order to take such decisions on the amount of resource to be allocated for a particular container, you can consider various design parameters, like for example, what kind of an application that particular container is going to host, what will be the maximum amount of traffic that is expected from that particular application, the amount of resources that are available in the underlying host machine, how many containers are we going to host in a particular Docker host, how to distribute the resources between all these containers. So you can take all those into consideration and plan your resource allocation for each container accordingly. So now let us move on and see another command in the Docker, which is docker kill. So we usually encounter certain situations in almost all the applications, or maybe even I can say electronic devices, that sometimes it just gets hanged, right? In such a situation, we won't be able to start it or stop it. We won't be able to perform any action, and it will simply come to a complete halt. And usually in such cases, what we do is we do a hard reboot, right? So Docker also has such a flexibility using the docker kill command. So I have created few containers here just for demo purpose. So say for example, container 1 got stuck and we want to just kill the process and restart it again, then we can give the command docker kill, and then we can pass the container name, which is container 1. So as you can see that the process of this particular container would have got killed. So now if we go to docker space ps command, then as you can see that this particular container 1 is not running anymore. But if you check docker ps -a, then you can see that the container got exited with error code 137, which means we have to manually kill the process in order to stop this particular container. So now in order to start this container, we can simply give the command docker space start, and then we can pass the name of the container, which is container 1. So as you can see that now the container 1 is up again. So if we give docker ps, so as you can see that container 1 is up and running again. So this is how we can give a hard kill to any process or container process, and we can bring that particular container up again. So having understood this, now let us move on to see the concept of port forwarding in Docker, where if you have hosted any particular application inside the container, and if it is accessible with any particular port of the container, then if you do port forwarding of that particular container port with your host machine's port, then you can simply access the application using that port in your external network. So now let us see how it is done. Let me take the same example of Nginx web server. Since Nginx is a web server, it will be accessible using the port 80. So now we will map the container's port 80 in which the Nginx application is running or the web server is running. We will access that port and we will link it to the host machine's port 80, and then we will try to access the Nginx web server in our local browser. So let's see how it goes. So now let us create the container with port forwarding. So we can say docker run -it hyphen name. Let's give a name to this particular container as web server, and then we can say -d, and then finally the name of the image, which is Nginx. So we can declare the port forwarding by using the argument -p, and then we can give the container's port 80 colon and then the docker host machine's port, which is again 80, using which we can access this particular container port. So this is how we can link the applications or containers 80 port to the host machine's port using port forwarding. So when we execute this command, as you can see, a container has been created. So now if we execute the docker ps command, so in the result, as you can see that the web server 1 container is up and running and the port forwarding is successful. So the container's port 80 is linked to the host machine's port 80. So now let us test whether the Nginx web server is accessible from the docker host machine or not. So if we execute the command curl localhost, then as you can see that we have a HTML file. This file is nothing but the default web page of the Nginx web server. So now if you open the same localhost link or your EC2 instance's public IP link in the web browser, it will automatically open that particular link in the port 80, which is the default port for HTTP. So as you can see that the Nginx default web page is also accessible in the browser, which means that we are able to access this particular default web page of the Nginx web server in our local browser. Just to give one more example, here is a command using which we can create a container of a MySQL database, where as you can see that we have mapped the container's 3306 port to the host machine's 3306 port. And also if you notice that we have declared few environment variables using the argument -e. If you are able to see the argument -e, there we have declared the password of our database or the root password of our database. So this is how we can declare environment variable using the -e argument, and also we can do port forwarding of our database using -p argument. So this is not something that we are going to execute, but yes, this is something just to give another example of the port forwarding. So now you would have got a basic understanding of how we can do port forwarding of our containers and how we can access the application from our local browser or an external network. So now let us move forward and see how we can create custom images of our containers. So till now what we have done is we just simply imported the images which are available in the Docker Hub in the public repository, which was created by someone else. So now what we will do is we will create a container, have our own configuration in the container, and from that container we will create our custom image, and then we will push it to the Docker Hub public repository so that someone else is able to use our custom image. So first let us see if there are any containers running in our Docker host. So as you can see, I have removed all the containers already. So now let us first create a container using the Ubuntu image. So we will say docker container run -it, then name, let's say web server. Let us run this particular container in detached mode. So we'll give D, and then finally we will give the name of the image, which is Ubuntu. So when I press enter, so as you can see that container has been created. So now let us get into the container by giving the command docker exec -it, then we can give the name of the container web server, and then finally we can give bash. So now we are inside the container. So now let us make our own modifications into the container so that we can create a specific custom image of this particular container. So we need to have certain modifications so that we are able to identify later that this container retained all the configuration that we made. So we will try to install the Apache software into this container. So currently if you execute service Apache 2, and if you check the status, it says as unrecognized service, which means this particular Apache software or service is not installed into this container. And before installing this particular software, let us give the command apt update. As the container is new, we will just update all the softwares. So now the software update is completed. Now let us try to install Apache 2. So we can give the command apt install Apache 2 and then -y. So as you can see that the installation is going on, allow it to complete. So we need to select geographical area and then the time zone. So the installation is completed now. So now if we execute the command service Apache 2 status, then as you can see that the Apache 2 has been installed, but it is not in running state. So we will simply start the service by giving the command service Apache 2 start. So now if we check the status, the Apache 2 is running. So now let us do another modification in the file system of our container where we will create one directory test. So as you can see that the test directory has been added to our file system. So this will also ensure that our custom image is able to bring all these configurations that we have made in this particular container. So what we have done till now, we have created a container using the Ubuntu image. Then we installed Apache into the container. And finally, we created a test directory in our file system. So these are the modifications that we have done in the container. So now if we create a custom image from this container, and later if we create a container from the custom image, then it should have or retain all these configurations that we have done, which means that the container which we are going to create from that custom image must have Apache 2 installed, and also it must have the test directory. So I am just giving this as an example, these two modifications, but you could imagine that if we had any other application data, like for example any configuration dumps or application files or scripting files or any kind of files or folders, then those files and folders will be retained in the container which we create from the custom image. So now let us come out of the container having made all the configurations that we had to do. So now if we execute the command docker ps, then as you can see that we have our container up and running now. So in order to create a custom image of this particular container, we need to give the command docker commit, and then we can pass the name of the container for which we want to create the custom image. In this case it is web server, and we can give the name of the custom image as web image. So let me execute this command. So now the custom image is getting built. So now the custom image is ready. So if we execute the command docker images, then as you can see web image is also shown in the output, and the size of this particular image is 264 MB. Now if you notice that we initially installed Ubuntu in our container which was of the size 74 MB, but now since we have Apache installed and also we have created one small test directory, so in total the custom image size comes out 264 MB. So now let us remove the container by giving the command docker rm-f. So we are forcefully removing the particular container and then the name of the container web server. So as you can see that the container has been removed. So now if we see docker ps-a, then we don't have any container, which means the container from which we created the custom image, now it has been removed from the docker host. So now if we execute the command docker images, as you can see that still we have the web image available. So now let us create a container using web image by giving the command docker run-it. Then we can give the name of the container as web server -d to make the container run in the detached mode. And finally we can give the name of our image, which is web image. And let us also do a port forwarding, so 8080. So now let us execute this command. So as you can see that a container has been created. So if we give the command docker ps, so as you can see that the web server container is up and running, and it has been built from the web image. Now let us try to get into the container and see whether our configurations based on which we created the custom image is retained in this particular container or not. So let us give the command docker exec-it, and then we can pass the name of the container and finally bash. So now let us check whether the Apache 2 service is running or not. So we can give the command service Apache 2 and then status. So as you can see that the service Apache 2 is running, and similarly we can also check whether the test directory is available or not. So if we give the ls command, then as you can see that test directory is also available in this particular container, which means both the modifications that we did on the container from which we created the custom image, which is installing and bringing the Apache 2 service up and running, and also creation of the test directory, is available in the container which we created from the custom image. So this is how we can create our own custom image, and we can create containers with same configuration which was available in the container from which the custom image was created. So I hope that this concept is clear. So now the next concept that we are going to understand is how we can use Docker Hub in order to upload our local images or custom images to the Docker Hub so that other developers or users can pull it for their own use. So in order to understand this, I'm going to explain this concept in the Play with Docker test lab, because if you are using this particular test lab, then you would want some of the explanations to be given in this test lab as well, so that you get used to using this particular test lab. All the concepts that we have covered till now we have done in the AWS account. So I thought that some of the concepts we should also execute in this test lab so that we get used to it. So now let me create a new instance. So now let us just ensure that Docker is is installed in this particular instance. So we can give docker version command. As you can see that the version is coming up, which means docker is up and running in this particular instance. So first, in order for us to push any custom image to the Docker Hub, we need to create a custom image first. So which means that we will have to build a particular image from an existing image. So let us see what are the existing images we have in this particular instance. Of course, we don't have any images. So first we will just pull already available Ubuntu image from the Docker Hub to our local instance. So the command that we can give is docker pull Ubuntu. So as you can see that the image is getting downloaded. So now if we give docker images, so as you can see that we now have the Ubuntu image, which is of the size 73 MB. So using this image, let us create a particular container where we will make our custom modifications, just how we did in the AWS account. So let us create the same setup in this particular test lab also. So first we will create a container. So we can give the command docker run -it, and then we can give the name of the server, let us say web server, and then we can give -d, and finally we can give the name of the image. Okay, so as you can see that a container has been created. So if we give the command docker ps, then as you can see our container is up and running. So now let us get into this container and make our custom modifications. So docker exec. So I hope that now you are getting used to these commands, like how to create a container and how to get into the container with docker run and docker exec command. So that is the main intention behind creating these container and pulling these images or making modifications inside the container again and again, so that in this training module you get used to such commands as much as possible. So after docker exec we can give -it, so that our interaction with the terminal is in the interactive mode, and then we can give the container id, or simply you can write the name of this particular container, which is web server, and web server is just an example, you can use any name, and finally we can give bash. So now we are inside the container. So first thing that we are going to do inside the container is just update all the packages with the apt update command. Okay, so all the default softwares are now installed. So now let us go ahead and install the Apache 2 service. So till now we have updated all the latest software into the container. So now let us try to install Apache 2. So we can give the command apt install Apache 2 -y. So let us execute this command. So as you can see that the Apache 2 software is getting installed. Allow it to complete. So let us give the geographical area, which is Asia in our case. So we can give 6, and then we can give the time zone. So the Indian time zone falls out 44, which is Kolkata. Okay, so the installation of the Apache 2 software has been completed. Now let us see what is the status of the Apache 2 service. So it is currently not running. So let us bring this up. So we can give service Apache 2 start. Okay, now let us see the status again. So as you can see that the Apache 2 service is running. So now let us create the second modification that we did, just to create another test directory. So this is our file system. Let us just give mkdir, and we will just create a test directory. And if you see ls, then as you can see that we have the test directory now. So these are our two modifications that we already did in AWS account. Now we have done the same modification in the container which we have created in this play with docker instance. So let us come out of this container and create a custom image. So we can first list the container by docker ps command. So as you can see our container is up and running, and this is the container which has our custom modifications. So let us create an image from this particular container. So let us give the command docker commit, name of the container, and finally the name of the image, which is web image. So if we execute this command, then as you can see that an image has been created. So now if we give the command docker images, then as you can see that our custom image has been created here. Don't worry about this particular image. I executed this particular command without giving the name of the image, so it just created a custom image with the name none, but just ignore this. But remember that docker commit, name of the container, and finally you have to give the name of the image. So we have executed this command correctly the second time. So hence we have the custom image now. So now what we are going to do is we are going to push this particular custom image into the Docker Hub. So in order to do that, you need to have an account in the Docker Hub. So I have an account in Docker Hub. So this is the home page of my Docker Hub account. So as you can see that currently we don't have any custom image or any kind of repository created in this particular account. And on a side note, it is very simple to create an account in the Docker Hub. So you can simply give Docker Hub in Google, and then you can create your own account in the Docker Hub. It is as same as creating an account in Gmail or any other open platforms. So once you have the Docker Hub account created, then you will come to this particular home page. So basically we have two options. One is to create a repository directly from the home page by clicking this button. So if you click create repository, then you will get this form. So you can basically fill the name of your directories and give some description. Then you can mention whether you want the directory to be in public mode or the private mode. So basically you can create both kind of repository. Either it can be a public repository or a private repository. And then finally you can give create. So this is one way of creating a repository, but we will be creating the repository directly from the play with Docker instance. So now let us go back to the play with Docker test lab. So as you can see that we have our custom image which we have to push to our Docker Hub account. So in order to push this particular custom image to the Docker Hub account, we need to first log in to our account from the test lab instance. So in order to log into the Docker Hub account, we need to give the command docker login, and then we need to give our username. So this is my username, and then we need to give our password. So this should be the Docker Hub account password. So as you can see that we are getting login succeeded, which means that I have successfully logged into my Docker Hub account from this particular test lab instance. So now in order to push our custom image, we need to give a simple command. But when we will give this particular command to push the custom image to the Docker Hub account, we will get an error. But I want you to see that error. So let us give the command to push this particular custom image to the Docker Hub account. So the command is docker push web img, which is the name of our custom image. So as you can see in this output that we are getting the error requested access to the resources denied. And this is happening because we are not following the naming convention using which we should pull our custom images. So Docker Hub requires us to push the custom images with a particular naming convention. And the naming convention is the username of your Docker Hub account / and then the name of the custom image, which means that if you see this Docker images output, here we have given the name as web img, which is not the right name to use for an image which we want to push to the Docker Hub account. So now we will create another custom image from the same container using which we can push that custom image to the Docker Hub account. And in this case, we will be using the correct naming convention. So let us go back to the same command which we used earlier to create this particular custom image. So this was the command which we used to create this particular custom image. So now we will change the name of the image. So in this command, all we have to do is to change the name of the image. So we will give our username of the Docker Hub account, which is, so this is the name of my username. So you can basically give your corresponding username. And after giving the username, we have to give a /. So Docker Hub requires us to push the custom image in this naming convention. So now if we press enter, then the same image will get created with this particular name. So now if we go to Docker images command, then as you can see that we have created another image with the correct naming convention. So if you execute the same command, docker push, and then you can pass the name of the image, can paste it. And now if you press enter, then as you can see that now the image is getting pushed towards the Docker Hub account, which is your public repository. So allow this push to complete. So now as you can see that the custom image has been pushed to the Docker Hub account. So now if we go to our account and refresh this home page, then as you can see that now we have our custom image in our public repository, which means that going forward, anyone can download or pull this particular image to their own instance or Docker instance, and then they can create containers from this particular image. So let us try this ourselves. So now if we go back to our test lab and let us now delete the custom image that we already have. So if we go to Docker images output, then as you can see that we have two custom images. So we will delete both of them, and then we will try to download the custom image that we have uploaded in our public repository. So first we will give the command docker image rmi, and then we will pass the name of the image, copy and then paste. So the first image is deleted, and now we will delete the second custom image also. So the second custom image also has been deleted. So now if you see, we only have the Ubuntu image. We don't have our custom images. So now let us try to download the custom image which we have in our public repository. And remember that since we have already given the docker login command, we are already pointing towards our own public repository. So if we give the command docker pull, and then we need to pass the name of the custom image, and we must continue to follow the naming convention, the correct naming convention, which is username / and then the name of the custom image. So as you can see that the download of the custom image is going on. So allow it to complete. So now if we check the docker images command output, then as you can see that we have pulled the custom image from our public repository. So similarly, you could imagine that you can basically pull any image from any public repository. You just have to give the name correctly by following the naming convention, and you can simply pull anyone's custom image from their public repositories. So this was just to give you an example from my account. So you can also try to pull this particular custom image from my account in your test lab instance, because I'll be having this particular image in my account. So you can basically basically try to pull this custom image in your instance just for practice purpose. So let us try to create a container out of this particular custom image and see whether the configurations that we have done, like for example installing the Apache 2 software, and also we created a test directory, let us see whether those configurations are still retained in the container or not. So let us create the container. So we can give the command docker run -it, then the name of the container, let us give the same name, web server, and then let us give -d to run the container in detached mode, and finally we can give the name of the custom image. So we have to follow the naming convention because this particular custom image is identified by the name which is having the convention, so we have to use the same name. We copy and paste it here, and then we can press enter. Oh, we have not removed the container, so our older container is still running in Ubuntu image, so we cannot use this particular name. So let us give another name, let us say web server 2. So now as you can see that our container has been created. Now if I go to the docker ps command, then as you can see that web server 2 is up and running, and it has been created from the custom image that we have pulled from the public repository. So now let us get into this particular container and see whether our configurations are retained or not. So in order to get into the container, we will give the command docker exec -it, and then we can give the name of our container, which is web server 2, and finally we can give bash. So now we are inside our container. So let us first see whether the Apache service exists in the container or not. So we can give the command service Apache 2 status. So as you can see that Apache is there in the container. It is not in the running state because we have not made the service up and running, but it is already installed in the container. So all we have to do is give the command service Apache to start, and now if we see the status, it is up and running. So basically the Apache 2 was installed in our container using which we created the custom image, and when we are trying to create a container out of the custom image which was pulled from the public repository, we are able to see that the Apache 2 service existed in our container, which means that particular service retained in the image. And second configuration that we was to create the test directory. So now let us see in our file system. So as you can see, we have the test folder also, which means this configuration also was retained. So it simply means that if you have a container with X number of configurations, right? You can have N number of files or folders or any kind of configuration in your container. If you want to retain that container, then you can create a custom image and you can store it in your public repository, or you can store it in your private repository or any particular registry. And later you can simply import that particular custom image and you can create your containers with exactly same configuration that you had in your container from which you created that custom image. So this was the concept that I wanted to explain. I hope that this is clear. Now let us move forward. So now let us see what are the other ways of sharing a custom image. So basically when we push our custom image to the public repository, what we are doing, we are actually making that custom image available for everyone to use. Similarly, we have some other ways using which we can make a custom image usable by someone else. For example, converting a custom image to a tar file. So once we have converted our custom image to a tar file, then we can simply pull it to our local system using WinSCP, or we can FTP that particular tar file to any other server so that we are able to share that with anyone else. And similarly, from that tar file, we can just simply create a container which will retain all the configurations of the container from which that particular tar file has been created. So now let us create a tar file from our image and see how we can create the image back from the tar file. So now we are back to our EC2 instance. So let us give the command docker ps. So as you can see that we have a container running which was built from the Ubuntu image. And now if we execute the command docker commit web server, and then we can give the name of the image. So now the image has been created. So our custom image has been created. So let us check the docker images output to check whether our custom image got created or not. So as you can see that web image has been created. So now in order to convert this custom image to a tar file, we can give the command docker save, and then we can give the name of the image which we want to convert to a tar file, which is web image in our case. And then we can give the greater than symbol, and then we can pass the name of the tar file to which we want to convert this particular custom image. So in our case, we will give myimage.tar, and then we can execute this command. So now this custom image will be stored in a tar file. So just remember that the command is docker save web image, and then we can give the name of the tar file to which we want to store our custom web image. So now if we give ls, then as you can see that the tar file has been created in our current repository. So now we can share this particular tar file to anyone, and also we can create the image from this particular tar file. So now let us remove the web image by giving the command docker rmi, and then we can pass the name of our custom image, which is web image. So as you can see that the custom image has been deleted. So now if we look at the docker images output, Then as you can see that the custom image has been deleted now. So now from the tar file, we can get back our custom image, which we created earlier. So in order to do that, we can use the command docker load, then the less than symbol, and then we can pass the name of the tar file from which we want to create the custom image. So now if we execute this command, then as you can see that the custom image has been created from the tar file. So now if we execute the command docker images, then as you can see that web image is now created, which means that using this particular image or the custom image, we can create our containers. And this particular container will again retain all the configurations that we had in our earlier image from which we created the tar file. So I hope that the concept is clear that how we can create a custom image and then we can store it in a tar file, and later we can send that tar, and later we can use that particular tar file to create the custom image. So now let us move on to see how we can create our own private registry in a particular server so that we can store all our custom images in the particular server. As you could imagine that having a private repository in a private server will be more secure to store all your custom images. So in order to have such a private registry in a particular server, what we have to do is we have to first pull the registry image from the Docker Hub. So registry image is one of the image which is available as open source in the Docker Hub in public repository, which we can pull to our own server instance, and then we can create a container from that registry image, and later inside that container we can store all our custom images. So this is the Docker Hub account. So here we need to search for registry. So as you can see that the first image that we have, we need to click this. So if you get into this particular image, then as you can see that we have the command to pull this particular image. And using this registry image, we can create a container inside which we can store all our custom images. So let us first pull the image by giving the command docker pull registry. So as you can see that the image is getting pulled, allow it to complete. So now the registry image has been pulled. So if you see docker images, now we have the registry image. So this is the command using which we can create the container from the registry image. So as you can see that we are doing a port forwarding with port number 5000, and then we are creating this particular container in the detached mode. And also we have a parameter called restart always. It means that whenever the container is down, then the restart will be automatically attempted, and it will be frequently attempted. And then we have declared the name of our container as registry, and finally we have the name of our image, which is registry, and we are downloading the version 2. So now if we execute this command, then as you can see that the container is getting created after pulling the registry image. So now if we check docker images, then as you can see that we have the registry image available with tag 2. So using this particular registry, we have also created one container. So if we execute the command docker ps, then as you can see that registry container is now running with port forwarding of 5000. So now let us copy the public IP address of our EC2 instance and paste it in the browser with port 5000 in order to open our registry service. So this is basically the URL using which you can access this particular registry service, which is the IP address, then port number 5000, and then we can give /v2 and then /_catalog. So as you can see that it shows us the repository which is currently empty right now. So if you upload any of your custom image here, then it will automatically reflect in this particular repository, and later you can fetch the custom image as and when required. So now let us list out the images that we currently have with command docker images. So as you can see that we have CentOS and Ubuntu images. So we will try to push one of these images to the remote private registry. So this remote private registry is currently hosted in our local host. But as you could imagine that you could simply host this registry in any of the servers, and if it is accessible from your current server in which you are working, then automatically you will be able to push or pull any of your custom images from that remote registry. And this will ensure more security and safety of your custom images rather than compared to storing all the custom images in a public repository or even a private repository in the Docker Hub. This is even more secure because your own private server is far more secure than all these other options that we have. In order to upload your custom image or any image to the local registry, we need to follow a particular naming convention of the custom image. So as we followed the naming convention for our Docker Hub repository, similarly even for a remote repository which you have in your private server, server, we need to follow a naming convention, and the naming convention is the name of the custom image should be the IP address, then the port number slash the name of the image, and then the tag of the image, which is in this case it is latest because we are going to send the latest version of our image. So this is the naming convention that we have to follow, but the command to set the name of your image which you want to push to a remote registry is docker image tag. So using this particular command docker image tag, and then you can give the name of the image that you want to push, which in our case is Ubuntu, and then you can set the name of the image as per the convention, as per the naming convention, which is nothing but localhost. In our case, since we have our remote registry in our localhost itself, so we are giving localhost, then the port number slash name of the image, and then latest, which is the tag of this particular image. So this is how we can change the name of the image that we want to push to a remote registry. So now if we execute the docker images command, then as you can see that we have a new image now with the correct naming convention. But if you notice that the image ID is same for both the images, which is Ubuntu and also the new image with the correct naming convention. So basically it has simply created a new instance of the image which we are going to push with the modified name. So now we can push this particular newly created image to the remote repository. So we can use the same command, basically docker image push and then the name of the image. So if you press enter, then as you can see that the image is getting pushed towards the remote registry. So as you can see that the image has been pushed to the remote registry. So now if we go to the browser and see, then as you can see that in the remote registry, Ubuntu image is now available, which means that from this remote registry, we can pull this particular image to any local server, provided if we have the access to this particular remote registry. So now let us go back and we will delete the current image and then we will try to pull this particular image. So we can give the command docker rmi ubuntu. So as you can see that the image has been deleted, and similarly we will also remove the new image that we have with the correct naming convention. So that also we will remove. So let us copy paste. So we are getting an error while trying to remove this particular image. It could be because one of the containers is running in the background with this image. So if we give the command docker ps, then as you can see that we have the web server container which is running with this particular image. So let us try to first remove this container. So we can give the command docker rm and then we can write -f and then we can pass the container id. So as you can see that this particular container has been removed. Now let us try to remove the image. So as you can see, image has been removed now. So now let us go back and see the list of images that we currently have. So we will give the command docker space images. So as you can see that both the images has been removed. So now let us try to pull the image, the custom image that we saved in our remote registry with the docker image pull command. So if we execute this particular command, then as you can see that the image has been pulled now from the remote registry. So if we give the command docker images now, then as you can see that we have our Ubuntu image back. So I hope that conceptually it is clear that how we can create a remote registry, how we can push an image, how we can pull an image. That was the main point. So from here, maybe you can try creating containers from this particular custom image and you can practice. But as such, on how to use a particular remote registry and how we can push and pull any custom image to any private server, that concept must be clear from this explanation. So I'm concluding this video to just keep the video length in control. So in this video, we looked at how we can create containers with limited resource, where we tried to create a container using a limited memory and also limited CPU. And then we saw how we can check the docker inspect command, what are the various information that we can find in the docker inspect command. And then we saw how we can use the docker kill command in order to stop and start a particular container. So for example, if your container is completely hanged and it is not responding, then you can always use the docker kill command. And then we saw how we can do port forwarding in our containers, using which we can map our local host or the docker host's port to the application port and directly access the services provided by the application which is stored inside the container. And then we saw how we can create custom image from our existing image or our existing containers, how we can create a custom image and later we can create containers from that particular custom image. So we saw both the processes, and then we saw how we can log in to our remote repository, which is the public repository available in the Docker Hub account. And then we saw how we can push or pull any particular custom image to and from the public repository which is there in the Docker Hub account. And then we saw how we can convert a particular custom image to a tar file, and after that how to use that tar file to create the custom image back. And finally we looked at how we can push and pull any custom image to a remote registry. So I hope that all the concepts were clear. If you like this video, then hit that like button, share it with other code lovers, and also subscribe to CodeFramer for more videos. Thank you and see you next time.